Hello ladies and gentlemen, today we're going to look at solving systems of equations. Your learning goals for today: I can solve a system of linear equations using substitution, and then also I can solve a system of linear equations using elimination. So we've looked at graphing systems already. However, graphing has some limitations. So I have my two lines graphed on this graph right here, on this coordinate plane. Notice how my solution is right here. I don't know what that point is, that ordered pair. I don't know the solution to this system. So we can't really use graphing for every single one. It's kind of hard to use. That's why we have other options. So we've looked at graphing already. And we're going to look at substitution and elimination or linear combination, depending on how you hear it, today. First, though, we're going to focus on substitution. So here's my question for you. What does it mean to substitute? Well, to substitute something is to put something in place of another. So if I had a substitute teacher in the room instead of me, that means that he got called in to be me, not because I'm gone, right? Well, substitution means to replace something. So what basically we're going to do is we're going to substitute one equation into the other. So you're always going to want to have a variable solved for. So basically it would be almost like solving for me. So notice how on this problem I have solved for y already. So what I'm going to do is, instead of seeing a y right here, I'm actually going to plug in 7 minus 2x. For y, because y is being substituted to become 7 minus 2x. Why is the reason? I can't solve 3x plus 3y equals 9 because I don't have I have too many variables. If I substitute in, I actually lose a variable. So let's try this. I'm going to take 7 minus 2x and plug it in for y. So I'm going to have 3x plus 3, oh, I hit y. Y I know though is 7 minus 2x. But it's still equal to 9. So basically what I did is I took that and I plugged it in for y. Let's solve for x. So I'm going to distribute that 3 in. Get 3x plus 21 minus 6x equals 9. Combine some like terms here. 3x minus 6x is negative 3x. Looks like I need to subtract 21. Divide by negative 3. I get x equals 4. Now, that's not going to help me. I need an ordered pair. Remember, it has an x and a y. So you're saying, well, what are we going to do? How are we going to get our y, Miss Marsh? You are going to take that 4 and plug it into this x right here. So then I'll get my y. So y equals 7 minus 2 times 4. So if I figure out what this is, that's 7 minus 8. So y equals negative 1. So I have my x and my y. My final thing to do with any solutions for a system is to write this as an ordered pair. So my answer or solution is 4, negative 1. Let's try another example of substitution. So very first thing I notice, I don't have a variable solved for. You have to solve for a variable to begin substitution. Now, don't be a hero. Try easy. Try to solve something easy. I notice I have this y that's doesn't have a number to it, just negative. I'm going to solve for y there. So I would, let's write this off to the side here. I'm going to add 4x, right? Got negative y still. I have that negative 1 kind of hanging out. So I got to divide by negative 1 on both sides. So I'm going to be left with y equals negative 4x minus 2. So I've solved for y. Now, what I'm going to do, can't plug that back in there. Otherwise, it's going to not make sense. It's going to actually give me 2 equals 2, which is true. I need to plug into the one I didn't solve for. So I solved for y. I'm going to plug in negative 4x minus 2 in for my y. I'm going to call in a backup, okay? Call in the substitute. So 7x plus 2 times, call the substitute in here, negative 4x minus 2, and that equals negative 5. So let's start solving for x. Distribute my 2 in, 7x minus 8x, right? 2 times negative 4. Minus 4 equals negative 5. Let's do some combining. 7x minus 8x is negative 1x. Add my 4. Divide by negative 1. And I get x equals 1. Now, gotta get my y. So I'm going to take that 1 and plug it in for the one I've solved for. Why would I plug it into something else? I'm going to have to re-solve. Save yourself time. Work smarter, not harder. So I got y equals negative 4 times 1 minus 2, or negative 4 minus 2, which is the same as negative 6. Last things, write as an ordered pair. 1, negative 6. So substitution is not too bad. Now let's look at the other option. So we've looked at graphing, we've looked at substitution. Let's take a peek at the linear combination / elimination round, okay? This is another method. You're going to find your favorite method. Some of you will like substitution more than elimination. Some of you are going to like elimination because it's easier and it's faster. Some of you, it's going to be easier for you to do substitution. So you'll find your best way. So what does this mean? Well, linear combination or elimination. Linear means lines, and combination means putting things together. And when you're eliminating, you're taking out things. So basically what we're going to do is we're going to add equations together, trying to eliminate either the x or the y. So that's going to be our job while we're working on this. Kind of like the Eliminator, Arnold Schwarzenegger. So let's try our first example here. I want to see if I'd add the two equations together, would I get a variable to cancel itself out? So if I add these two together right now, I notice 5x minus 5x cancels out and we get 0x, right? Which is just 0. That's what you want to happen at all times. So let's add the rest. Y plus 3y gives you 4y. 6 minus 22 is negative 16. Divide by 4. So I get y equals negative 4. Now, need my x. Problem with elimination is you kind of have to plug it back in. Not an easy way to plug it back in. So I'm going to plug into the top. I could plug into the bottom. Why I'm plugging into the top? Easier math. I always go for the easy stuff. So I plugged in my negative 4 for my y. Let's add 4 to both sides. Start solving here. Divide by 5. I get x equals 2. So x does in fact equal 2. I get an ordered pair. Whoopsies. 2, negative 4. Let's try one that's not exactly set up for elimination. Alright, so I need to figure out a way to eliminate a variable. I look for easy pickings, right? Work smarter, not harder. I notice that I already have opposite signs on both of them. That's good. You need opposite signs. Now, I need to have the same number. 4 and 3, I'm going to have to multiply a little bit more to get my answers. Notice how I have a 3 and a 1. Let's multiply the bottom by a number so that I'll get a 3 there. So basically, I'm going to multiply the bottom by 3. So top's going to stay alone. Let's multiply. So I got negative 3x plus 3 times 3, 9y. 3 times negative 5 is negative 15. Notice, my x's have now canceled out. wonderfully. I am now going to have some easy solving. Negative 4y plus 9y is 5y. Negative 5 minus 15 is negative 20. Let's divide by some 5 here. Y equals a negative 4. So now I need to get x. So let's plug it into, let's go to the bottom. It looks a little easier on the bottom. Negative x plus 3 times my y, which is negative 4. And negative x minus 12 equals negative 5. Add 12 to both sides. Negative x equals 7. Divide by my negative 1. X equals a negative 7. So my ordered pair, negative 7, negative 4. Wonderful. Let's try example 3. This is the last example we're going to do together. I'm going to do it by elimination. So, neither of them are opposite signs. So I got to make sure I multiply by a negative at least. What should I multiply by though? I could multiply this by negative 3, right? That'll give me a negative 3 out here. So let's multiply everybody by negative 3. So I'm going to get negative 3x plus 6y equals negative 12. Let's rewrite the bottom one here. Negative 3x plus 3x, that cancels out. 6y minus 6y cancels out. I'm left with 0 equals negative 4. 0 doesn't equal negative 4. You know what? I bet this system doesn't have a solution. That can happen. What this looks like. This basically is going to look like a system where you have one equation that looks like this and another equation that looks like that. They're parallel lines. They never intersect. They are a no solution. There's another option you can possibly get as well. You can get two of them that are the same exact line. That's when you get 0 equals 0. That is called an infinite solution. Infinite solutions. Okay? So watch out for those. That can happen. Just be careful and just keep it in mind when you're working on a problem. You get something that looks a little funky. Alright? And that's the end of this video. See you later, Sabers.